Hi, everyone. Welcome back along to the show. Today, I have with me Jyotika Singh. Jyotika is the Director of Data Science at Placemakr. And can't wait to hear a little bit more about what she does. But more importantly, we're going to be talking about the applications of natural language processing, NLP, which Jyotika is a bit of an expert in. Really pleased to have you on the show, Jyotika. Thank you very much for coming along.
Thank you so much. It's a pleasure to be here. And thank you for the introduction. I work as a director of data science at Placemakr, which is formerly known as Y Hotel. It's an alternative hospitality service provider in the US that operates short stay pop-up staffed hotels, as well as serviced apartment programs in newly built luxury apartment buildings. They have permanent locations as well as pop-ups where they offer a blended hospitality experience, and is currently operating 8 properties across the US. So I would absolutely recommend that for a stay if any of the listeners are ever visiting US or in the locations where they're Placemakr properties. My personal favorite feature there is that most of the units have a kitchen, and that just makes things really easy. There's leftover food when you're visiting any other places, and it just gives you flexibility of doing something with it the next day, or just taking care of your own breakfast in your own way. So that's that.
Brilliant.
My background is that I graduated from BITS. I did my undergraduate studies in electrical engineering, and then I did my master's from UCLA in signals and systems.
Right.
Right after that, I got the opportunity to do a lot of natural language processing. I was working in a startup called i6 Media, where we had just a lot of text data from social media, from all these other sources. And that gave me an opportunity to really advance in that field. We also published multiple patents in machine learning and natural language processing. And that sort of introduced me to this field. And ever since, it's been a great ride.
Did you go to them because you got to work on NLP, natural language processing, or did you sort of pick it up and get into it while you were there?
Great question. So a little bit of both. What happened is during my master's at UCLA, I was really into signals and systems, and I was looking at speech data a lot. So speech is also natural language data. But when we say natural language processing, it's more often than not referring to text. But that's how really I got into natural language processing. And then one thing led to another. And then I got into the field of text data like that.
Right, got it. I mean, you just sort of touched on it there, but it's worth us just touching on what natural language processing is and what it isn't. You just mentioned there that you normally mean text, but you talked about speech. But for me, speech you turn into text, and then you can do some natural language processing on it. So yeah, just what is it? What's the field? What does the field encompass? And where do people normally get that wrong? What do they think is NLP, but maybe it isn't?
Yeah, so NLP, which stands for natural language processing, is all around processing of natural language. And when you say natural language, what does that mean? So language is general, is how people communicate across. It can be in spoken form, it can be in text. And natural language is something that humans have been using in time, and it's something that has gone through evolution and is really diverse. So what I mean by that, for example, probably 15 years ago, or until 15 years ago, people hadn't heard of abbreviations like BRB and LOL, and they all came into effect once texting got more prominent. So these are just some examples of ways that natural language evolves over time. Yeah. And it's just so diverse, right? There's so many different languages in the world, and not just that. Everybody has different styles of talking, their different dialects, different accents. We can just say the same sentence in so many different ways too. So there's a lot of diversity in language. And natural language processing is anything which is as basic as counting the word frequencies in a piece of text to a computer actually being able to understand what sentence you just said or wrote, and is able to understand, comprehend that, and then actually come back with a response that answers the question asked. So all of that, is included in natural language processing.
Gotcha. So yeah, I understand. So when I ask Alexa, who I'm now worried is going to respond to me, to turn the lights on or off, that sounds like that's using natural language processing to understand what I'm saying and then run a command.
Yes, that's absolutely correct. What you say is, broken down into like comprehend what are you trying to do? Are you turning off your living room light or a room light? Is a device like that set up? So yeah, the processing of the language and coming up with a response when Alexa tells you, yeah, it's done, or if you ask a question, whatever response Alexa comes up with, natural language processing, there it is.
So what generates? Obviously, there's text generated all over the place. So it's maybe a bit of a broad question, but what generates text? I suppose in relation to words that need to be processed and analyzed.
Yeah, well, a lot of text data is generated across the globe, and there are different ways to look at it. So from a pure industrial perspective, when there are companies and organizations trying to do natural language processing on text data, there are a few different sources that are very popular. So some of them include reviews, review comments left by users of particular products or services. There's blogs and media. There's chat data, specifically customer service chat data when you're interacting with any business that way. And then there are these products and services that business sells. There's a lot of description around them, what that product really is. There are a lot of documents data. There's forms-based data, search-based data. And then also going ahead in like an educational industry vertical, there's also papers, research papers, so like those large sort of document type data. So those are some of the sources of data that industries can produce themselves as well. But often that is appended with other data sources as well. So there are other publicly available data sources that organizations or in an educational setting can be used to create a model or enhance a model. And these include like government data, there's census data, there's data sets that are published by research labs from different universities or large organizations that are made public. So people are able to use them and access them. And lastly, there's also conditionally accessible data. So for example, any social media platforms like YouTube, Reddit, Twitch, and so on, they have this API, and there's data that is publicly accessible there, but you have to agree to their terms and services, maybe enter a plan with them, and there's like free version, a paid version with like different parameters. So there's that data source as well, which is very popularly used.
And that's access to text data that's produced on their platforms. So like obviously Reddit is mostly streams of comments that people have made and articles people have posted, but sort of something like YouTube, the descriptions or the comments that people add to videos and that kind of thing.
Absolutely. And I think that's a great point that you bring up. When you think of YouTube, you're like videos, but there's just so much text data that is on YouTube. Video title, video description, the content creators, channel descriptions, all the comments that have happened on the videos themselves, the categorizations of the videos, and there's a lot of text data in the play.
Yeah. Great. So there's a whole load of text data that is produced either consciously or subconsciously in some instances that where you've given examples there. I can see as you were sort of going through those examples, different industries that those apply more than others. Reviews, yes, lots on kind of product reviews and review sites, hotels, bookings. Starting to now piece together why this is important for Placemaker, by the way, the reviews on properties. But of course, then you start to think about documents more generally. You mentioned research papers. I can think sort of law firms who have reams of case history. If that's been digitized, you've got government papers that have been written that publish sort of policies and those kind of things. So I can start to see different types of data being relevant to different industries. Do you tend to see that, or is it a little bit any industry can have kind of access to any of this data?
No, that is absolutely correct. There's different types of or different sources of data that could be relevant to different industries, and it varies so drastically. And even the kind of language you'd expect, like you mentioned, it just varies really drastically from something like social media with a lot of informal language and informal dialogue. There are no grammatical rules, or you can type anything as a comment on social media, right? Versus a more like articles or research papers where there's some sort of grammatical construct that is expected in the text and some sort of rules, that are followed within the text. So yes, that is absolutely true. It depends on the industry vertical, and different data can come in handy for different types of applications.
Cool. I'm going to come back to language in a minute because I got a question that I wanted to come to about how this changes across the globe, because obviously not everyone speaks in the same language and also not the same dialect. So I want to come back to that off the back of us talking about how this kind of data is used. So data is just data, and obviously it's useful for the people consuming it on a sort of, almost sentence by sentence or word by word basis, depending on what they're doing with it. But from a kind of processing point of view and maybe data science perspective, how are these things used, and what kind of things are they used for?
Yeah, great question. So, well, I want to start by saying, firstly, data is not enough, right? So you need to have the right data that is relevant to your use case. And sometimes industries don't have this data already, or they may have the data, but it's either not labeled or it's not in large enough quantities. So that's where you want to look beyond the data that you have and look at publicly available data sources that you
Right.
can append, that you can leverage to really build your model. And sometimes the data set is different from your problem at hand, and you're still able to leverage a model that was built on a different data set, and that is called transfer learning. Basically, you're transferring the learning from one domain or one type of data to another data set, and that
Okay.
that does work pretty well in NLP. But once you have the right data, there's definitely considerations you need to think about when you're processing it. So starting with, what databases are you going to store your data in? Because with text data, there are some databases that are specifically designed to handle operations you want to do on text data. So like document
Right.
databases, Elasticsearch, MongoDB. And then you also have to see how you read the data, because data can be in so many different sources. On one hand, it could be coming from an API request that you make to YouTube, versus it could be sitting in files, versus it could be sitting in scanned documents like PDFs. And there are different ways you can actually extract text data out of that to do operations on. So that is an important part of the puzzle as well before you
Right.
go on to pre-processing. And then you're pre-processing your data, there are other set of challenges that come in. Because natural language is messy, there are very few rules and it evolves over time. You have to clean, you have to denoise your data before you're able to numerically transform. And then once you have your numerical transformations, it's really any machine learning step. After that, you see if you want to use a pre-existing trained model or you want to train your own model, build a pipeline, get feedback, update your model, evaluate. So the standard machine learning steps after that. But I do want to say the most important one, I feel has been relevant in all my experience, has been the human element that helps to understand business use case. Because
Right.
you have text data and you want to do something with it, but the most important thing is, what do you want to do with it? And understanding that and taking that into consideration when you're building your model, so you're able to write test cases, in that fashion, and you're also able to identify any issues in the data, because use case
Right.
really helps you think about how this is going to be used, how your model is going to be used, what is coming out of that. And that is just a really important factor in the mix.
Yeah. The context, the business context, the use case context is always important with these things. I just want to go back actually. So you sort of talked through there the kind of stages of preparing data ready for analysis, and you sort of talked through how the database, how it's going to be read, the pre-processing, the cleaning. I think you used the phrase denoise. I have not heard of that before, but I assume that's removing noise
Yes.
from the messy data. But then you sort of then go, and then we just do some ML to it. So is natural language processing the sort of complexity of it, or the biggest consideration of it it's pre-analysis? Because once you're at the point of analyzing it, you've basically turned it into more structured data sets. So actually the work of natural language processing is to put some structure to that sort of unstructured and messy data. Is that right? Or actually is some of the smarts in the algorithm and the machine learning or the data science you apply to the data once it's sort of at a transformed state?
Yeah, so it really depends on the application, but yes, the cleaning of this text data does take considerable amount of time, and most of the applications that exist in natural language processing, just because you don't there's no fixed format that the data can be in,
Yeah.
and if your data has noise, that's going to flow through your model. So that's definitely something that takes the longest. And you may have heard, in a job of a data scientist, the majority of the time taken is around data and
Yeah.
preparing your data and cleaning your data. And that's definitely true for language data as well.
Right. Right. And is there something special or secret or different to the way you have to do that with text data? So, when you're cleaning up numerical figures and addresses and things like that, there's certain patterns and rules to follow. Is there something different and secret, so to speak, of how natural language processing is? There some special rules that are applied to this kind of work, and is that proprietary, or is that now more kind of like available and you can just deploy it to natural language?
Well, I would say most of it is available, and it's been, something people have been exploring for a decade or, more
Mm,
now. But
mm,
yes, there are some standard processes to follow. For example, if you're expecting like no sort of grammatical structure in your data, so let's say it's coming from some social media platform, then
yeah.
you may have like excessive punctuation or some typing errors. So some of the processes can be removing all those punctuations, removing stop words, which is basically, to complete a sentence, you need words like is and that
Mm,
and the. But if you're creating a bag of words model where you're just taking word frequencies and doing something with it, these words don't hold a lot of meaning. You really care about,
right.
other more important words. So, for example, I am in this podcast. So, podcast is the important word,
Mm,
but in am, all of those words are just extra that are needed to complete this sentence.
yes.
But for a model, it may not be relevant. So removing some of these words, standardizing some of the words. So for example, location, you can say United States of America or USA or US, and there are a few different ways, to refer to a location. So you
Mm,
may want to standardize some of that so that everywhere in the text it reads as one particular, name that you can process. And then there's also other processing like stemming, lemmatizing, which basically reduces the word to its base form. So like
right.
cars and car reduces to car. Uh, so there's a lot of this processing that you have to choose based on your application, but
Yeah.
there are very popular techniques there, and there's a lot of open source tools available to help you implement these. So you don't have to every time write code from scratch for sure.
Yes, and I guess also you don't want to have to think through. Someone has done the thinking already on those
Yes.
examples about how to deal with USA and US and United States of America. So you don't have, not everyone has to kind of come up, think of all the scenarios of how words will be said. But I've seen, particularly, and you mentioned before about sort of chatbots, particularly sort of customer service chatbots, where you can tell that all it's doing really is picking out the key word in what has been typed, because it interacts with you like it's kind of human, and
Yeah.
you write colloquially and in short form because you're in a rush and you're annoyed normally because you're contacting customer services. So you sort of put a sentence in, and you can see it's just pulling out a key word, and it often misses the context. It sees that I said United States of America, so it just assumes that that's what I'm talking about, rather than I've written I don't want anything to do with the United States of America, and that's what it should have understood. So it feels like it's more than just kind of keyword identification, but is that part of this process, or is that part of more really how you apply the data once you've got constructed it?
Yeah, so actually, that's a really great example that you brought up with the chatbots. And when I said it sort of depends on application, that's a perfect example to summarize that. And it's because if you are building, let's say, a text classifier model, and you just want to identify, let's say, the category of, or like the topic of what's being spoken about,
Hmm.
maybe the way the sequence of your words is not important. You just care about those keywords, and you can build a model that way. But then there's some tasks where the sequence of words, plays an important role.
Right.
And then going on to another topic that you mentioned about the chatbots is that not just the sequence of the words, but also the context really matters. So,
Hmm.
for example, two sentences, one where you say that, server, can I have the check? And the other sentence is, I just crashed the server. So the
Hmm.
server word is the same,
Hmm.
but it means completely different in the two different examples that I just
Yes.
said. And it really depends on the context. So when I use server with crash, that's particularly probably the server that we are hinting towards.
Yeah.
But when you are using check with server, that's the context. So that really holds another meaning.
Hmm.
So there are a lot of context-aware models that, there's a lot of research going on, transformer-based models, which is a particular type of neural network architecture, But there's a lot of research going on how to make these language models better, how to make language model tasks better, and how to take the context into picture and actually do it in a way that takes reasonable amount of time as well, because these models can get vastly big, and it may not be practical for companies of all sizes. So there's some trades-off and considerations when it comes to that.
Yeah, I can see that, and if I start to think about global companies that have operations in multiple countries, even English-speaking countries, where the dialect is different, the pronunciation is different, the level of sarcasm you use, all these things, I can imagine start to essentially screw the model. So do you need to, do you tend to sort of have a base set of sort of base characteristics of how language is used, and then that's, I don't know, tweaked or refined or tailored for the certain audience or the certain group of people that are going to be interacting with it?
Yeah, that is again a really, really great point you bring up. And yes, because there are sometimes words that you even write differently, like theater with a RE or an ER. Depending on your location, it can mean the same thing.
Yeah.
So yes, there's a lot of normalization techniques that can be done. So those sort of words are identified correctly, and that's sort of in the data cleaning processes for sure. But also these latest large models are just learning from data on their own too. So when they see occurrence of these words, they're able to basically learn that a theater with an RE is the same as a theater with an ER, and it's just probably coming from like different locations, but the model is able to learn rules of language, rules of grammar, rules of tenses, plurality, and all of that. But also again, like sometimes it's not always that easy. It requires a lot of compute resources to build a model that is really working very well, and so you often have to start with the baseline, and that baseline may not be perfect. And what you see in a lot of the chatbots out there today is that definitely there's going to be some places it's not going to do well, but it would do well on majority of the use cases. And if that happens, companies roll with it. They're like, yeah, this works 80% of the time. That's fine. And then they work on improving it in time. So it may not be the most sophisticated ways or most state-of-the-art ways that companies usually deploy. It really depends on what sort of trade-off is there in terms of complexity of the model that you're using, and what application it's for, and what is a decent performance.
Right. I imagine there's quite a lot of human testing required on these things, right? How do you go about, with all data and models and everything, you need to kind of ensure that the output meets the use case and the need, but also doesn't do the wrong thing, doesn't take you down the wrong direction. And I can imagine you've got a similar thing here where we need to test these things, right? We need to test that when we say you theater in theater or type theater in theater, it picks up what the right thing to do is. How do you begin to start testing these things so that you pick up whether it's doing the right stuff or not?
Yeah, well, a lot of it is a lot of the times it's manual. So you are really, you have a team who's just sitting and trying these arbitrary test cases, which is why also having teams that represent the people that are going to use your products. Having diverse teams plays an important role. But really, it's making up test cases and also opening it up to a smaller pool of audience and collecting feedback. So like collecting test cases and then looking through like what really happened here and identifying cases where it didn't do well, where it did well. So a common approach is to take a subset of data just to test. And so, for example, if it's doing like 90 out of 100 samples are getting classified correctly, or it's doing a good job, then I know, okay, like maybe from 1,000, it's going to hold the same ratio. So it's really taking that small subset and running those tests, and keep updating your data as well, because language changes and evolves over time. So you definitely want to make sure it's working on what's going on right now versus maybe if your data set is 10 years older, it may not necessarily translate to the topics of conversation today.
Yeah, you mentioned that earlier about evolving the model. This thing, it's not build a model or a data set and then leave it. As you say, it's the kind of thing, because it's interacting. Most use cases, actually, I think there's some examples where this isn't true, but certainly, as you say, social media, the way you talk to a voice assistant, what's typed in or spoken on a telephone sort of IVR type thing. I can imagine, because it's, as you say, live, real humans talking. That's going to evolve. That's going to change as language does naturally. So you have to sort of keep an eye, keep updating, keep iterating the data that it's used, and testing that it still produces good results.
Yep. Just like any machine learning system.
Yeah, no different. Surprise. So I want to just touch on some more use cases if we can. So we mentioned there the examples that we've either inadvertently or subconscious or purposefully spoken about is around chatbots. But and you touched on data sets earlier, but some of the other kind of practical examples of how this is being used for real by companies, either your own or experiences that you've got in other industries. The sort of the practical application of this technology.
Yeah, so there are actually a lot of industry domains that are actively using NLP-based products and applications like real estate, finance, social media, marketing, travel and hospitality, healthcare, e-commerce, insurance law, and the list is probably longer than that. But I'll start with talking about a few examples that you and I may have seen. So does it ever happen with you that you're searching for, let's say, king bed on Google, like a king bed sets, and then an hour later you see an ad for king mattress on Facebook? So that's really your search data being analyzed in a way and drawing that connection between a king bed and a king mattress, and that's why you see relevant ads.
Right.
But not just that, like your email, you see there's like a spam folder there, and your email is very accurately, maybe a little degree of error, but is able to distinguish between your regular email and spam email.
Yeah.
So and then again, another example that you and I would have definitely seen is like when you're online shopping, you're browsing through products. On the side, you see recommendations of products that are similar to either the one that you're browsing or your past purchase history or your past searches. So all of this uses some amount of natural language processing in the back end. There's also language translation. Today, if you want to translate something, you can quickly type it on Google, use the translate, and get the translation out.
Yeah.
And all of that has a lot of large language models behind it as well. And now a little bit industrial specific examples. And this one's quite interesting, actually. So Elon Musk once tweeted about Signal and asked his followers to use Signal.
Yeah.
Now, what that happened is that led to more than 1,000% surge in an unrelated stock with a similar name.
Yes.
So that's how social media data also impacts all these different industries. But then looking at industries very specifically, in real estate, there was one report that said that analyzing hidden values from text descriptions increases the property value between 1% to 6% on an average. In insurance, there are a lot of natural language processing based document classification application. And Cynozure, the company, claimed the solution provided 30% more accurate classifications than when they had to do the process manually. Furthermore, Lemonade provides personalized insurance policies and quotes to customers through the use of its chatbot called Maya. And one of its success stories is that the chatbot's ability to process a theft claim for a piece of clothing for close to $1,000 within 3 seconds.
Wow.
And then there are also some other examples in like oil and gas. Shell has its own chatbot or virtual assistant that you can ask, you can chat with, you can get help on a lot of technical topics. And then in telecommunication, there's a company called Telenor, which is a large Danish communication company. They built a natural language processing algorithms to streamline their customer center function by analyzing communications and emails. So it would suggest appropriate answers in response to a particular question. And their NLP algorithm attained apparently an 80% accuracy rate and significantly improved the time to respond rate. So, those are some industries that are definitely very obviously out there using natural language processing. But then there are also some others like, oil and gas and automotive that are using, but, it's still in the nascent stage. And there's a lot of research going on that, guides us onto how natural language processing can be really helpful in different applications in those domains. But, it's not totally out there yet. So for example, a paper in 2019 explored text-based crude oil price forecasting approach using deep learning, where they actually leveraged data from crude oil news column from investing.com.
Right.
And then, while we wait for the industry of autonomous vehicles to become more mainstream, there are many companies that are integrating AI into existing vehicles for supporting drivers and passengers. So for example, Mercedes launched its AI-powered OS in A-class cars in 2018. And basically that agent, that system responds to conversational commands of drivers using natural language processing power technology. So it combines that question of the driver with other data like pad roads, vehicle location, weather information, and uses that to actually interact with the driver.
Yeah, it's interesting on that last one, actually. I think voice, I mean, I've only been in a small sample of all the cars, I guess, but a voice in cars still isn't as good, as good as that should be by now. If you you can obviously get Alexa in some cars and things like that now, and Siri, but I still don't see that has sort of kept up with the almost the in-home and the phone level of interactivity with voice. You want to be able to say, direct me to the nearest petrol station, and it just, I don't know, it's just not that easy yet. It doesn't quite work as well as that yet.
100%. And there's so much research though, and it takes some time when there's a research invention versus when it's like very widely accepted and followed and implemented. Sure. But there's been like a 44% annual growth rate of patents and publications over the past 5 years in NLP in the autonomous vehicle space. So we're getting there, and probably in a few years, we'll see the technology improve a lot better.
Yeah. Brilliant. Well, so many examples from so many industries, and as you say, there's kind of there's sort of an endless amount of text that exists. So therefore, there's probably an endless amount of use case of how it can be deployed. But coming up with the thing that will add the most value. Back to your point at the start, the thing, not just looking for somewhere to put NLP, but finding use cases that require that kind of data, and then finding methods to process it feels like the order of the day.
Yeah, cool. Absolutely. You're right. I agree completely.
So obviously one thing it was worth sort of mentioning as well, and you mentioned to me off air, is that and I'm very excited by this because I've done this, which is you're writing a book on the topic of NLP. So do you have a name for this book? Is it work in progress?
So a potential name for this book is Natural Language Processing in the Real World. Okay. And yes, it's a work in progress. I am very close, and it's probably going to be sometime next year when this book is going to be published.
Okay.
But you're right; it's really about the what and the how. So we spoke a little bit about applications of natural language processing across different industries, and my book does contain applications of natural language processing across like 15 industry domains. And nice. When I started thinking of this, I was like, well, my motivation came from like a few examples that I read was. For example, James Dyson created the Dyson vacuum cleaner design as an inspiration from how sawmills use cyclone force to eject sawdust. Right. Another example is in the mid-90s, a children's hospital in the UK improved its ICU handoff process by consulting with the Ferrari F1 pit crew team, and their error rate reportedly reduced from 30% to 10% with the adoption of the new techniques. Now, you never know what inspires something completely different, or in a completely different setting, in a completely different domain. So it's really good to know the sort of applications of a particular type of data, because its adoption across domains is just massive in NLP. So the book really has these applications, but also how to actually go about building them using Python programming language and using the tools available to us. So it covers all the natural language processing basics, sources of data, data curation, and code samples of actually reading this data from different data sources, like we spoke about, like PDF, scan documents, can be so many different things. And then data augmentation, pre-processing, transformation, modeling, followed by like standalone NLP utilization tasks that help with full-fledged applications. So examples would be information extraction, text summarization, topic modeling, classification, language translation, text similarity, sentiment analysis. And then these actually go into building these full-fledged applications like chatbots like recommendation systems, like customer service analytics, which uses all this data and different standalone NLP utilizations to actually build this sort of a product from start to end. So it really covers all those applications and all those implementations as well. So like a guide for users, or really anybody who wants to do something with text data. So it can be data scientists who know a little bit about natural language processing already, but need some help with that. Or it could be other data practitioners, ML engineers, even product managers who have data in their companies or in their organizations, but don't know what to do with that and don't know how complex it would be. So this would be like a guide for anybody who's trying to explore this field and actually build applications or learn about applications and see how they can build them using tools available to everybody.
Amazing. Well, I massively commend you for penning this book. I know how much work and effort and energy and passion and drive and desire and coffee it takes to write this kind of thing. So congratulations just for getting to the start line. But yeah, I'm looking forward to seeing that and helping you promote that when it's available.
Thank you. Thank you so much. I appreciate
on doing that.
Thank you.
No worries. And listen, thank you so much for coming onto the show. It's such a broad topic, NLP, and I knew a part of what you talked about there, but there's so much to it and so many applications that it can be applied to. So yeah, massively appreciate you coming on the show. And yeah, thanks for coming along today.
Well, thank you for inviting me. It's been an absolute pleasure talking to you today. Thank you so much.
No worries. And thanks everyone for listening. I hope you enjoyed that. And we'll, as always, catch you again soon.